Today we're going to be talking about this lecture 2, the expressions and assignments. So, phones in the pockets right now. In the pockets. Yes. That's better to have them in front. I don't want to see in front of you because they're going to call you. So just keep them in the pockets. Okay. This is one of the most important. As I told you, this course, it relies mainly on what we see in the first weeks. So the first weeks are very important to get out of the class while you understood everything, inshallah. So if you have any question, you ask it right now. So what we're going to be talking about is the basics of what we are going to be needing for the programming. So these are some of the basics. So let's start. First of all,
can we see this is the base for the whole Java program?
Yes. Whatever we're going to be seeing, this is the base of what we're going to be doing in this class. So let's talk about these things. First of all, we're going to be working with data. And mainly data comes in whatever we're going to be using in two types, mainly. Either they are numbers or they are letters. So with numbers, this is the numerical. Okay. With the letters, we call them literal. And then there's another type which is very specific, which we call it logical, because it has like two cases. I mean, it's either true or false. So, sorry? Well, this is going to be used when we ask some questions. We would like to see if this is true or false, but this is actually something that we can use also without if or for. So this is just the basic data types that we can have to manipulate data. What kind of data types that we're going to be manipulating? They can be numbers, literals or texts, or logical, which are Boolean. I'm going to be detailing all these. So the numerical values, they can have two types: whole numbers and real numbers. Real numbers are the numbers with the decimal value, and the whole numbers are like the ones without decimal value. Why we need to do this separation? If you remember from last week, we said that one of the main things that we need to do, we need to speak the same language with the computer to be able to give him some instructions, give it some instructions. The second thing is that we need to simplify our thinking, because we humans, we think with the high level of complexity, and we need to lower it down. Now, if we're dealing with the computer, if I'd like to give the computer a number, I need to give it what type of number is it? Is it a whole number or is it a real number? And I need to specify that to the computer, because the computer is just a machine. It's not like a human. For a human, you can just put, let's say, if I put something like this, this is 1, or I put something like this, 1.5, we can distinguish between these. This is clearly a whole number, the first one, and this is a decimal value. But for the computer, we need to tell him, I'm going to give you a whole number, I'm going to give you a decimal value. So it's very important to simplify whatever we're going to be doing. And even though, for example, this one over here, 1.0 and 1, for us these are the same thing, right? Yeah. Because 1.0 and 1, that's the same thing. For the computer, that's completely different things, like potatoes and tomatoes, whatever. It's something completely different. So you have to be careful when you deal with the machine, that now, when you're going to give the machine some values, you have to specify what type of values are they. And actually they come in different flavors, let's say, in different sizes, to be more precise. So like, for example, for the whole numbers, just need to erase and go back to 0. There are different sizes for the whole numbers, and also there are different sizes for the real numbers. and for the literal there's only one size, and the logical only one size. These are data types. Do you need to memorize these? Well, you will have to memorize them while you're going to use them. You're going to memorize them. For now, for today, I want you to understand them. So what are these? This is like when you go to, I don't know, any fast food chain or any restaurant, sometimes they give you the choice. Do you want to have the drink like regular or medium or large? It's the same idea here. It depends on what's the value that you're going to put in this, because these are like data types. What's the type of value? Is it a small value, a medium value, a big value? So like if you are on the billions, you're going to use something like long. If you have something like 10 or 12, you're going to use something byte. And so on, there's a range between those. Okay, so for now, don't get into the details. We are going to understand actually the details of all these. But just to give you an idea, these are like big and small sizes, different sizes of values. So we give them different names if they're whole numbers or real numbers. So for real numbers we have like only two sizes, and for these whole numbers we have four basic sizes. Yes?
It's bigger.
Yeah, from the smaller, yeah, exactly, true, very good. I just need to find out again, yes. This is smaller and this is bigger. So byte is very small and short bigger and so on, yes.
If the value is less than 2 to the power 7, I have to use the byte.
Well, I don't want to get into that detail because this 2 power 7 everything, it's I don't want to get into that level of complexity, but just now to understand that, later on we're going to get into those numbers. What's the size, how do I know the size and everything. But for now, just don't focus too much on that. What's important for you to understand, they are sizes. And depending on different values that I'm sending to or I'm going to give to the computer, or I want the computer to work with, I need to tell the computer, actually I want to work with numbers of this size, or that size. That's the thing. Later on, we're going to get into the details. What's the maximum value for byte, for example? Or what is the maximum value for int? Well, we are going to be talking about those, inshallah. And these are the ranges for those data types. So each of those data types, they have a range. But before talking about those range, the size of the values that you can put in, we need to understand that if we would like to put a value to tell the computer to work with a value, either we're going to give him to give it a value or take a value from the computer. You remember from last week we were saying that everything that happens goes through the RAM. If I'm typing something from the keyboard, it goes to the RAM, the CPU. If it needs to be displayed, it goes to the RAM, and then the output, the screen, whatever. The RAM is the centerpiece of what we're going to be working in. If I'm telling the computer, take this number, well, you have to save that number. Where is it going to be saved? In the RAM. So the RAM it's like a big place when you have a lot of boxes where you can put different information in them. But these data types, depending on their size, they take one or more boxes. So if you imagine that this is the RAM, and the RAM has, let's say, different places when you can put some information. So some data types need only one box, that's enough, because they're small enough. But some others, then they need more. So let's say, for example, 1 byte, let's say 1 byte is 1 box. 2 bytes, that's 2 boxes. For example, if you use a char, if you store something in the memory, this is going to be stored in something that takes 2 boxes. So everything has a size. This is how you can understand this memory used. And it gives you an idea about the size of those data types.
Do I need to memorize the chart?
No, you don't need to memorize any of these. You're going to be using them, and by using them, you're going to memorize them. But now I just want you to memorize that these, okay, there's some, oh, interesting. So we are disconnected. That's nice. So we said that these, whatever the memory sizes, these are actually the sizes of what you need to memorize. Excuse me? You don't have the same screen. We just give it a time, which is going to appear, inshallah, because it takes some time to show up. Don't turn on the screen, you're going to break it. It doesn't show up on your screen? I'm recording, you know, every time we have these interruptions, I have to do some editing, which takes a long time. And if so try to, you know, avoid having if I have problems with computers, it doesn't work, whatever, just give it some time, it's going to work later on. Because we had some interruptions, but, you know, every time. So we were saying that these are the different sizes, okay? And the bigger the number of bytes is, the more memory you take. That means the bigger the value you can save in that data type. And to give you an idea about the type of values, so you can see, for example, for a byte, it can take values from -128 to +127. So these are the ranges of values. So if you have, for example, you'd like to store some values that are like 200. This value 200, can I put it in a byte? No. So the closest one that I can use is short. But can I use int? I can use int. Not a big deal. It's not a problem. So I can use, but I'm using a lot of memory. So that's the only thing. Now this is very important to know when you're dealing, for example, if you're programming for some applications to be run on the phone, where the RAM is quite small, is different than if you're programming for the computer. For the computer, you can just, okay, there's plenty of RAM, maybe I can use it. But still, every time you need to use something, just have in mind that it's better to use only what you need. So if you need only a small set of size for the memory, because the values are small, but 4 mega, but it depends. Values for 4 mega. What do you mean 4 mega? Because we were talking about bytes, and then now we're talking about mega. It depends on the RAM. Even now, you have 10 gigabytes of the RAM. But if you need only to use 1 byte, why are you going to be reserving 5? You understand the idea? If use only what you need only 1 byte, use only 1 byte. If you need more, you need more. If you don't know what you might need, it might be just small or big, then you take the big, because you don't know. Maybe the big can accommodate the small, but the small, you cannot grow to become big. Okay, so that's the main thing I'd like you to get from this this slide. One of the things why we said that these data types, we would like to store them, if we'd like to access and tell the computer, please remember this value, save it into the RAM, I need to use a variable. What is a variable? It's like this box in the memory that I would like to reserve. If I'd like the computer to remember something, to save something in its memory, I need to tell the computer, look, I need this type of size of memory, and I'm going to give it a name. So every time I tell you this name, this is going to be that place in the memory. And this is what we call the variable, because whatever, it's like a box. What goes inside can change, can vary, but the box is the same. But it's what we put inside. It's like a cup. You can have a cup and then you put water or tea or coffee, but the cup stays the cup. And then what changes is what's inside. The same idea with the variables. And this is our way if we'd like to save something into the memory. And this is what we're going to be using. The variables need to be declared before being used. Okay, this is declared. This is a very important keyword that you need to remember. Declaring a variable means I'm telling the computer, note that I want you to use this size and give it this name, because I need to store this type of data inside of it. So let's have a look at what I need to give to the computer, I need to write something like this. Remember from last time, we were using system.out.println to print something on the screen, and there is a semicolon at the end, because every instruction in Java, most of them, they are going to end with semicolon. So this is how I specify to Java that to reserve a space in the memory for me, I need to tell Java what's the data type of that space, and I need to give it a name. Yes?
What's the meaning of compiler?
The compiler is what we've seen, probably we've seen that anyways. The compiler is what converts your Java code to the machine language. Let's say something like that.
Yeah, the one in between.
Exactly. Because we convert our language to Java to be able to convert from Java to machine language. We cannot just convert from our language directly to the machine language. So that's why we're using programming languages. So this tool that allows to convert from the Java language or any programming language to another machine language is called compiling. This process is called compiling. I'm simplifying because Java has a different type of compiling. It has another step. It creates something in between, and I refer you to the video of the first week. Go back to it, it's explained there. So just, you can go back, it will refresh your memory there. When I was talking about that's compiling and how Java works and how compiling in Java works. Abdullah? Yeah. Thinking too much might be a way to sleep. So, in Java, this is how it works. I specify, let's first have this look. I specify the data type, and I specify the name. Why do I have to choose a name? Because what happens if I would like to use more than one box in the memory? I need to give to tell the computer I need to use this first box 1 and this is box 2. How the computer will know which box I mean. So that's why I need to specify, okay, reserve this place, give it this name. If I tell you put something in that box named with the name that I used, then he knows where to put it. The computer knows where to put it. So that's why this is how it works. We use data type and variable name. Or there's another way to do that. We can use data type, variable name, and then we put some value inside of it. As an example, we can have these type of declarations. Okay, so have a look at this. I'm declaring a variable named x, and what is data type? Int. Int is real numbers, is for real numbers or whole numbers? Whole numbers. Double is for real numbers. But then I'm doing something that I didn't speak about, I didn't talk about this. What is this comma doing here? Exactly, because I'm declaring more than one variable of this data type. So x is int, but I have y and z that both of them are double. So I can do this using this comma. And I can put this, if you'd like to really understand this, this is not an equality. This is not x is equal to 5. This is not like that, because we're not in math class. In the math class, we might understand that x is equal to 5. But this is programming class. And in this class, we give instructions to the computer. Declare x as an int. This is an order. Yes. Declare double y and z as double. This is an order, an instruction that I'm giving to the computer. The computer has to do something. Now, if I'm doing this, it means put 5 inside of x. This is how we should read it. Like? The algorithms? Well, maybe, yes. But it's not like substitution, because you do not substitute. It's like an instruction, do something. And what it is going to do, take this value, put it in this place. Take this value and put it in that place.
Change it into 5.
I prefer put it.
Put it instead of
So let's say this is x. And if I'm executing this instruction, I'm going to put 5 inside of x. I have y equals 7.32. Well, same process. Put 7.32 into y. put 9.8 into y, and so on. What happens if I do something like this, for example? I'm taking what this means. Okay, now let's understand. What did I say that this instruction means? Put 1 in x. This was what's going to happen. This 5 is going to go, and I'm going to put 1. This is every time we let's say we agree on an understanding, we need to keep doing the same understanding, because not sometimes it means this, sometimes it means that. Every time when I have something like this, it takes a value, put it somewhere. What happens to the previous value? It's gone. Because I said, take this value, put it in this place. That's it. Even if there was a value before, no problems. I throw that value and then I'm using a new value now. The same instruction. Because the same meaning.
The same last instruction, right?
Sorry?
The same last instruction.
The same last value, you mean?
Yeah.
Because if I have these two instructions to execute one after the other one, it will delete the previous value and keep only the last value.
And the semicolon to finish the
Instruction,
instruction?
yes. Every instruction you have semicolon. Yes.
What does it mean, this nearby 5?
Which one?
This one, like,
The semicolon here? The semicolon is Java, actually not only Java, many programming languages they're using that. They're using this to specify that this is an instruction and this instruction ends here with the semicolon. Because we can have many instructions, but we separate each instruction by a semicolon. Okay? These are other types of declarations. When I'm declaring, and at the same time I'm putting a value. So that means it's like having like two instructions in one line. This is actually equal to int a and a equal 16. So these two instructions, they can be summarized and put in one line. Actually, this is something that you're going to see many times, because programmers are lazy typing people, and every time we can shorten something, we're going to try it. So this is a short way to write. Instead of writing two lines, we write only one line. That means declare a as an int and put 16 inside of a. Two things in one line. Same thing here, except that there are more than two things. I'm declaring b as a double and putting 5.5 inside of b, and declaring c as a double and then putting 8.11 inside of c. So this goes here, and this one goes here, and both of them, a and b and c, both of them are double. Okay. By the way, this int and double, these are the main things that we're going to use. This is the big size for real numbers, and this is some relatively big size for the whole numbers, because there's a bigger one which is long, but this is okay. Int most of the time has the same size as long. Okay, now let's have some rules in terms of the names of the variables. Now we use variables as x, a, b, c, but sometimes you would like to use more than just a, b, c, and would like to use something like a word. What are the conditions for these names to be valid? Java variable names are valid identifier. You have to memorize this as well. Identifier for us now, it means a variable name, but it will mean more things than just that. But for now, just an identifier for you is just a variable name. So there are some conditions that I need to have to put on the variables names, and these are the conditions. It should not start with a number. It should consist only of letters, digits, numbers, or underscore. You know the underscore? What you have in above the minus and next to the zero, when you shift, there's this long line which comes on the bottom, yeah, exactly. This is the underscore. So when we say consists only of letters, digits, and underscore, what is left? Like what? Plus, minus, exactly. These are not acceptable.
Caps.
The caps, what do you mean caps?
The capital.
Capital letters are acceptable because they are letters. But you cannot use a space, exactly. A slash,
Equal.
or backslash, equal, semicolon, comma, dot,
Squares.
the brackets, exactly. All these are not valid. Exclamation mark or a question mark, these are not good things that are not acceptable characters in a variable name. So there are three conditions. The first one, it should not start with a number. The second one, it should consist only of letters, numbers, and underscore. The third one, it should not be a Java keyword. I cannot name a variable int or double because it's already used. These int double are used by Java. So there are a couple of things that are used by Java, then I cannot use them. But for now, we might not know a lot of them, but we're going to learn them as we advance in the programming. You have to know that Java is case sensitive, which means capital letters and lowercase letters are different. For example, if you have this rate like this with capital R, is completely different than rate with lowercase. You can declare two different variables, one with capital R, the other one with lowercase r. These are completely different things. So capital letters and lowercase are different.
Different in name.
What do you mean in name?
Like it's a different name for a value.
Exactly, it's a different name for a variable. By the way, I forgot to tell you that you cannot declare this two variables with the same name. You cannot declare variable int a and then double a or int a again. It's not possible. You declare the variables only once and then you use them as much as you want. But when we're talking here, if you use int a lowercase and then you use double a capital A, these are two different variables. This is what I mean by case sensitive. Lowercase and uppercase are different. Let's ask some questions about what do you think about these? The first one, is it a valid? Is it respecting all the rules?
Valid.
This one.
Invalid.
Which rule is not respected? The third? Is this a reserved word?
Literal.
Well, it is not a reserved word. We don't know the reserved words. The reserved word that you know up to now is int double. So who told you that this is count? Not because this is English, that means this is a reserved word. This is not a reserved word, and this is legal. Because it doesn't start with a number. It consists only of numbers, letters, and underscore. There are only letters here.
Literal.
Sorry?
Not literal.
But what do you mean not literal?
This is Java is 3 times, yeah? Numeral.
It doesn't have to be. It can have. It can have. It doesn't have to be a letter and a number and underscore. It can maybe only letters.
No, you ask about this count. You ask
Yeah, is it acceptable or not? So it is acceptable because it respects this rule. It's not starting with the number. And to respect this rule, it consists only of letters, digits, and underscore. Well, there is no underscore, no digits here, only letters. That's fine. And it is not a reserved keyword. It is not a reserved keyword. So this is why it's legal. What about the second one? It's illegal. Why? Because it starts with a number, so this is not acceptable. What about this one? X1. Legal? Everybody says legal? Yeah, it starts with the number. Yeah, so it doesn't start with the number. It respects all of these. What about data 1?
No, because of the function mark.
Because what?
Because that's not underscore.
Because this is the minus. This minus is not acceptable, and this is why actually this is not legal. What about this one?
Legal.
Not legal.
Legal.
Legal or not legal?
Legal.
Why not legal? Well, does it say this should not start with underscore? It just said dot start with a number. It can start with the letter, it can start with the underscore. So this is legal. What about this one? Illegal? Not legal? Why? Because of the dot. Exactly. We don't. This is not acceptable. Very good. Mashallah. We're doing good. So this, every time you're going to choose a name for your variable, so make sure that it respects those conditions. Don't put spaces, don't put dots, don't make them start with a number, and the rest is don't use a keyword, a Java keyword. Okay, so we've seen that if you'd like to put something inside of a variable, I can use this equal sign. Okay, this equal sign doesn't mean this is equal to that, but it means put this in that. So we put any expression or value, we put it inside of a variable. So what we want to make you understand here, what happens if I put a variable name on the right side of the equal sign? So now look what I'm doing. I'm declaring 3 variables. So, and I advise you, every time you have some problems like this, go visual. Declare those variables like I do. I'm representing those variables like boxes, so I can put something inside of it. So this is X, this is Y, and this is Z. Okay? So in this declaration, I need to put 5 in. What about Y and Z? Well, I'm here in this instruction. I don't know what to do. Yes?
Yeah, y equal to x plus 2. We have to add 2 more.
Well, this is after I'm coming here. I'm just real. I'm just in this line. This line is what it does. So now I'm not doing anything for Y and Z. Now let's execute this line, because this is how the computer works. Executes line by line. So we finish with the first one. We go to the second one. Y equal x multiplied by 2. When we have the variable on the right side of the equal sign, this means look what's inside of that variable and get the value, and then use that value in the calculation that you need to use. So this means look inside of x. What is inside of x? So 5, this becomes 5. 5 multiplied by 2, 10. So this is now equal to 10. What am I doing with this 10? Put it inside Y. So now this is going to have 10. You got the point? If this is X, we don't see this as somewhere where we store something, but we see what's inside of it. But on the left side of the equal sign, this is always a place where we put something. So this is a place where I'm putting something, and this is what I'm taking something from. What about this? Oh, I forgot. I shouldn't remove this. X was like this, Y, and we had Z. It was 5, 10. Now if I'd like to execute this line over here,
10 plus 5.
this is 10, this is 5. So 10 plus 5 is 15, minus 20, minus 5 that I'm putting inside of Z. So this is how it works. If I'm asking you this, what happens if I do something like this? Y equal Y plus 10. Error? No. It's not an error. Sorry? What means 20? The same things, exactly. It gives us 20 because we apply the same rules. What is inside of Y? 10. So 10 plus 10, that's 20. So this becomes 20. What am I doing with this 20? Put it inside of Y. What was inside of Y is going to go, and I'm putting the 20 inside of it. Where is 10 gone? 10 is gone because I replaced it with another value. So the same principle applies. Don't get fooled when you see the same variable on both sides. Not a problem. It's okay. Yes? What does it mean? Here, the comma here means my instruction is not finished. I would like to declare X, and then I'm doing something else. I'm declaring another variable. So this is how to separate between the different variables. Yeah, the comma means x, this is the first variable, and I'm putting 5 inside of it, and then I have another variable, and I have a third one, and I separate between them with the commas. Yes, thank you for the question. All right? So this is what we've been talking about. If we use the same variable in both places, actually this is going to be adding different values. So now count, it has 5. At the end of this, what is the count what is going to be inside of it? So it's going to be 5 or 7? 7. It was 5 before. Then when I executed this one, it takes 5 plus 2, that's 7. And now I'm putting 7 inside the count. So at the end, I'm going to end up with this equal to 7. There's something else that I can do. So I told you, we are going to see some shortcuts. If you see something like this, what does this mean? Put 7 in number 2 and put 7 in number 1. This is just the same thing, but just sometimes some more shortcuts. Okay, let's talk about something that now we talk about is initialize a variable. When we put a value inside a variable, the first value is called the initial value, and that's why we say we initialize the variables. So like for example this one, in this line we declared the variable v1 and we initialized the variable v1. Two things in one line. In this variable v2, what did we do? Did we just declare or did we just initialize? We just declared. So you need to remember those terms because they are going to come, and in the quiz come in, inshallah, you're going to have these terms to deal with them. So this is just declaring without initializing. I'm not putting anything inside of it. Right. No, I just specified the box. I didn't put the value inside of the box.
You declare.
Yes, like this, for example, in this v1. I declared the box and I put a number in that box. But what about v2? I declared the box, but I didn't put anything inside of the button. So no initial value, so I did not initialize the variable v2, and I initialized the variable v1 with 5. So when I'm putting something, I always say that I'm initializing the first value. There's always a good practice to always initialize your variables. Why is that? Because if you just declare, let me give you an example. If you just declare something, for example like this, and then you put v1 equal v2 plus 2. This looks good, but there's a problem with this. What's v2? You did not put any value inside of it. So this is going to be a problem potentially. Why I say potentially? Because actually Java is going to put a value for you. If you don't do this, if you don't put a value for int and doubles, Java is going to put 0. If you don't put it, it's going to be there. But as a good practice, don't let the computer do some things for you that maybe you might forget that he did that for you, and then you get lost. Why is this 2? I was supposed to be 5, so whatever. So you have to be careful and take as a practice. If you declare a variable, put something inside of it. Even if it's 0, just put it there. This is something that we say in the good practice of the programming. Okay, now we're going to be looking at some interesting things. Again, this might be a bit twisting because these are some sort of shortcuts for some things that we know. But these shortcuts, we're going to use them. So let's have a look at those things. If you have some instructions like this, you can convert them to look like that. Name of the variable equal name of the variable, a certain operator expression. You can use this writing. Why? Because it's simpler. You don't have to write this twice. So for example, if you use count plus equal to, what this means? What does just mean? Count equal count plus 2. Sum minus equal discount. So sum is variable name. Operator, this is the operator, minus. And discount is the other expression. So this is going to be sum equal sum minus discount. This is just another way to represent things. It's just shorter. As I told you, we like things to be short because you don't want to type more. So that's why sometimes you're going to see something like that. One thing, when you have something like this with two variables, it's important for you to realize that there's a parenthesis. Because this expression, all of it is, this amount is multiplied by count 1 plus count 2. Both of them. So we need to have the sum before adding that. Anyway, you're going to get, inshallah, used to. If you're not used to, not a big deal. You can use this way, because it's simpler for you. And inshallah, you're going to see, you're going to be starting using this one because it's shorter for you. Yes?
So it will be sum, then multiplied by the amount.
Which one? This last one? Yes. Yeah. This is going to be summed first.
Then multiplied.
Then the result of this is going to be multiplied by amount. All right? So these are shorthand assignment statements because they just shorten the instructions. Now let's have a look at these arithmetic operations like the plus, the minus, the multiplication, and the modular division or the remainder of the division. You know what this remainder of the division is? Probably not. The what? The remainder of the division. Well, it's almost there. It's not 0.2 actually. Let's say if you have 10 and you divide 10 by 3. So 10 divided by 3 is going to give you not 0.3.
The remainder 1.
It's 3 point something, okay? Let's just say it like that. It's 3 point something. Actually, it's 3.3333, whatever. But now, if I divide 3 by 3, it's 3. But what is left after I have this? This is the 1. Before I go to the decimal values, what is left is 1. And this 1 I need now to divide by 3. Well, actually, we don't divide by 3 with this modular division. If I'd like to get this 1, if I write 10 modular division 3, it's going to give me this one. So if I'd like to have this one, this is how to get it. This operator over here is like it is the remainder of the division. I always explain it this way because I think it's easier. If you'd like to really understand this remainder or the modular division, imagine like you're a father of 2 or 3 kids. You're a father of 3 kids, and you have 10 cookies to give to your 3 kids. But you don't want to give any of your kids more than the others. So if you have 10 cookies, and you cannot cut those cookies in pieces, you have only 10 cookies to give to 3 kids. How many cookies are going to give to everyone? 3, 3, 3, 3, 3. What's going to be left for you? 1. 1 is the remainder of the division. If you have 10 cars to give to 3 people, how many cars are going to be to give to those people, and how many cars are left after you give everyone the same amount? So you give everyone a 3, 3, 3, you still have 1 car left. Okay? So this is the remainder of the division. Is it easy for you?
That's for prime numbers, yeah?
It's the percentage sign, but this is not percentage. Yes, it's a percentage symbol, but this is not percentage. For Java, this is not percentage. Yes, just give me time to finish, and yeah, go ahead.
That's for prime number. I can't.
No, it's not for prime number. I'm going to give you another example. If you have, are you ready? Okay, I'm going to give you something. If you have 5 cars or 5 smartphones to give to 2 people, what is the remainder? How many smartphones you're going to still have at the end? 1. Very good, because you gave 2, and then 1 is left, so you keep it. Very good. If you have 7 smartphones to give to 14 people, how many smartphones are going to be in your hands when you give everyone the same amount?
Please 14.
You have 7 smartphones. How can you end up with 14? 33. I have, mashallah. I would like to have that with you. Okay, let me do something. I have 2 markers to give to all of you. And I need to give each one of you the same number of markers. How many markers will be with me after I give each one of you the same amount of markers? I give you 0, but how many are left with me? 2. I don't give anyone because I'm just with everybody got the same number of markers, 0, 0, 0, 0, and I end up with 2. Okay, don't get confused. Okay, what I would like, the reminder is what is left, not how much I give. So if I have like 5 cars to give to 6 people, how many cars I'm going to have at the end? 5, because I cannot give you. If I have 5 cars and I give to 5 people, what is left? 0. Exactly. So this is what you just this is how you try to remember this modular division. Okay, just what is left after I divide, and this is what is left is there. Okay, and that was just to talk about this modular division. Why did we talk about this one? Because we would like to add and subtract and multiply and divide. When we are going to be dealing with numbers, in our first programming tasks, we're going just to deal with these small operations. How to add 2 numbers, how to calculate the average of 3 numbers, something like that. And so in order to do that, we need to look for these operators because there's something special about them. I need to understand that these, they have some sort of order. Okay, what this means is that this table, this slide, you need to come back to it from after a while, just to whenever you go to understand that when I'm having this means one thing. If you're trying to mix different data types, if I'm adding, for example, 5 plus 1.2, okay? So, well, this is not a very easy 2, but let's imagine that this is 2. Okay, 5 plus 1.2. 5 is an int, which is a whole number. 1.2 is a real number. So how can I mix these two? Is it possible to mix? The result is? Well, I'm coming to that, but before this, can I mix this? Yeah, I can mix it. It will give me the result of 6.2. So this is what this means. If you use something which is, let's say, a whole number, and then you mix it with another smaller number, another real number, then the result is going to be the real number. Because we can always use a smaller in a bigger one. Or even with another example, maybe let me give you a better example like this. I don't know if I have, okay, I don't have that. Before going there, if I have, let's say, int n equal 5 plus 1.2. The result of this is 6.2. Is this, what's the data type of this 6.2? This is a double. Can I put a double in int?
Yeah.
No. Int is here, is smaller. Double is big. Can I put something big in a small box? It's going to overflow. I cannot just pour something that is big from a small. But I can put something small in a big. So this is not okay. But if I have something, let's say, double. Let me just clear this. If I have double n, and I put 5 inside of it. Is 5 an int or a double? 5 is an int. But I can put an int into a double because 5 is an int, and int is smaller than double, so I can put a small value in a big cup. That's not a big problem. But I cannot put a big value in a small cup. So you just to remember these things. Okay, so this is what this means. You have to, if you have a small value, you can put it in a bigger box, but the opposite is not right. Is that okay? There's something else that you need to know, and this is also interesting. When you divide and you do some operations, when you divide different data types, like for example, you divide, this is a double that you divide with an int. You're mixing two data types. The result is going to be a bigger data type. So 15.2 is a double, and this is an int. When you have an operation between a double and an int, the result is double. You agree with me, right? This is normal, this is logical. And actually the computer is programmed to understand this. But there's something interesting that you need to know now. If I'm using int with an int, the result is an int, not a double. What do you mean false? This is not true. In our word, yes. If you divide 15 by 2, you will never get 7. You get 7.5. But when you're working with computers, this is not the human word, this is the computer word. In the computer word, if you use an int, you divide it by an int, it will give you an int. So 7.5 is not an int. So what's going to happen to this 0.5 over here? Actually, when it divides 15 by 2, it gives you this result. But when you try to fit this in an int box, no way. So in order to make it fit in the box, it's going to throw this 0.5. Sorry? Because it just throws the rest. It just keeps what it has, it throws. It doesn't do operation. It just throws. It doesn't round. It just throws. It just cancels the decimal. Even if it's 7.9, 7.9, if you try to put this as an int, it's 7. So, very important. When you're doing some operations with your values, you have to put the phones in the pockets and not take them back. And then pay attention to having the same data type for both your operators, and just make sure that you do whatever you want to do, because if you'd like to divide and your result is a double, make sure that this is one of them is double. That's why 15.0 is like 15, but actually for us it's like 15, but for a computer it's completely different. It gives you a completely different result. Is it clear for this part?
15.0 is a show.
A double.
Double. 0.0.
15.
What if it's only 15?
This is the result. This is what we're going to talk about.
No, 15. It could be int, right? Only 15.
Yes, when we talk about only 15, this is what we are going to talk about. This is the result that you have. When you use 15.0, this is the result that you have. Because this is double with int, so the result is double. This is int with int, the result is int. Double with, not only divide, with plus, with minus, with multiplication, any operator. Double with anything and any operation and another int, the result is double.
But int is only a real number. Without
No, int is not the real number. Int is the whole number. You get confused.
like 1 or 3 or
Yeah, 1, 3, 5, minus 2, etc.
without null.
Without the decimal values. Yes. Okay, and my question now. What happens if I divide 15 by 2.0? 15 by 2.0. What is the result? 7 or 7.5?
7.5.
Okay, you say 7.5. Some others are just looking for me to say what is the right answer. But 7? 7.5? Well, the right answer is 7.5. Why? Because we said just you have a double and an int. We didn't say the double have to be first or the int have to be first. If you have like 5 ints and 1 double, No problem. 1 plus 5 plus 2 plus 7 plus 1.2. Everything is going to be double just because of that double, even if it's the last one. Okay? If only one double is somewhere, the result is going to be double. So this is the thing. It doesn't have to be the first one. Okay? All right, and let's move on. Yeah, this is the part where you wanted to talk about this. The part. What happens if I'm doing something? Is this valid? I mean, is this okay to put this type of? This is a double. I'm trying to put a double in an int.
No, you cannot.
This is not possible because from big to small, not okay. Well, I'm going to lose something. Actually, I'm going to lose the 0.8. So this is not the good way to do it. So this is not a valid. What about this one?
Yes.
Int. If I put an int inside of a double, that's fine, because smaller values can be put in a bigger box. What about this one? Short.
No, you can't.
And this is 14.3. This 14.3 is double, so no problem. Well, this is a problem. We cannot put a big value in a small box. What about this one?
That's valid.
Valid.
This one is tricky.
Invalid.
This is not valid. Why is it not valid? We just said that if it's a real number, we can use it in store it in some real numbers. And float and doubles are like the big size and small size. Float is the small size, and double is the big size. So why then 9.2 cannot be put inside of float? Because by default, when you put 9.2, it is meant to be double, not float. So 9.2 is a double, and this is you cannot put a double inside of a float. You can put a float inside of double, but double inside of float, not possible. But how can I represent a value that is decimal value with a float? Actually, as we said, decimal numbers are like that. If you'd like to, no, before this, if you'd like this to be valid, but now how to do this? Okay, let me discard. Let me show you something. And can I go down? Maybe if I do something like this, float f equal 9.2 f. And this is going to be valid. So you just move this a bit downstairs, just to show you this. Okay, so this one is not valid because for floats, this is how it works. So I told you now the computer is not a human. Okay, so we understand 9.2 to be 9.2. What is the f there? Because actually the difference between this 9.2, which is a double, and 9.2, which is a float, is in the terms of the size. Just to give you an idea about what's the size for a real number. For a whole number, we know that the bigger it is, this is the bigger the size is. But what is the size for a float number? The size for the float numbers, of the double numbers, is the number of a letter of numbers, sorry, after the decimal value, decimal separator. After the dot, how many numbers I can save in a double, and how many numbers I can save in a float. Just to give you an idea, maybe if I have this 9.2, okay, and if it's in float, it's going to be 9.2 and 1, 2, 3, 4. Let's say, for example, 5 numbers after decimal place. Let's say something like that. For the double, it's 9. For the computer, this is how it works: 9.2, and let's say 10 numbers. So it's 9.2222, whatever. So the double can hold many numbers after the decimal value, while the float can just hold a little less. That's why. By default, if you put 9.2, the computer is going to understand that this is double. If you want it to be something else than double, you have to put the f. Or what we're going to explain now, do some typecast, some conversion. You can convert from a data type to another data type. And this is what we're going to learn, inshallah. So to convert, we need to typecast. This is what we call typecasting. And this typecasting is what it means, just convert it to this data type. How to convert? Using this data type between parentheses. So this means 2.9, this is which data type? Float or double? No, the value here is double. And when I put between parentheses now, this 2.9 is going to be converted to int. What is when we convert 2.9 to int? What is going to be?
2.
Very good, 2, not 3. And this 2, I'm going to put it inside of x. This way, I'm doing things properly. I know what I'm doing. I'm telling the computer, convert this to this data type, and then save it inside of int. So I can save 2 inside of an int, that's fine. So this is the typecasting. And I can just remember that I'm not going to round, I'm just casting. That means I'm going to convert this to 2, not to 3, because 3 is very close. No, just delete the decimal value. Okay, what about now this? What is the value of d? And you have something like that. So we have n is 9, m is 2. d is equal to n divided by m. What is n? It's 9. And what is m? 2. 9 divided by 2? 4.5. So inside of d, what I'm going to see? So the value of d is 4, not 4.5. Actually, when you divide an int by an int, the result is an int, so that's why this 0.5 is going to go. It's 4.5 if one of them is double, but this is int and int. Okay? Int and int, it will give you an int. But if I'd like it to be double, I can do something like this. But notice now, d is a double, right? And here d is double. But because I'm using int with int, the result is going to be int. But now I'm using int with double, the result is going to be double. So this is going to be 4.5.
So we can put double inside n.
Inside n? What do you mean inside n?
We can convert n to double.
How?
Instead of n.
Yes, yes. You can. One of them has to be double. Just one of them has to be double. It doesn't have to be m. This is just one example. If you remove this, even if you keep this and then you put double also here, it's fine. Because double with double gives double. Yes? It's double with double, give you double. Not a problem. Yeah, 4.5.
What about float with float?
Float with float, it will give you a float. No.
With double?
And then the result is going to be saved as double, that's fine. Float with double is a double. Because remember, we said float is smaller than double. So if you have float with float, you can put a float into a double, not a problem. But the opposite is not right. Yes. Yeah. So this is, we lose the fraction, and this is we have the fraction. Okay, one interesting thing is that the precedence rules. This means that which one we start first when we have something like this, for example. What is the result of this operation?
Start from -2.
So am I going to start from multiplying this first, or maybe just doing this first, or how am I going to calculate this?
I think multiply the biggest.
Well, there are some rules. First thing, I'm starting with the unary operators, like this -2, some others that we're going to see later, plus or not equal to. We're going to see those later. So there's some unary operator like these ones. We're going to start with them. So this is the first thing that we're going to do. The second thing that we're going to look at, check those that have multiplication or division or moduli division. These are the ones that I'm going to start with. That means I'm going to start with these, and then what about these ones? All of them have the same weight. So if I have this, which one I start with? The one on the left. If I have of the sum of them that are on the same level, like these ones, many of them, I always go from the left to the right. Every two from the left to the right, and so on. And the last thing I'm going to do is the plus and minus. So I have this plus, I have plus and minus, so this is going to be calculated first, and the result is going to be added to the result. These are what we call the precedence rule. Which one we start with first? Very important. We don't start with the multiplication. We start with any of those. If multiplication happens to be the first one, that's fine. So if multiplication is here, it doesn't mean we're going to start from here. We always start when they have the same weight, that we start from the left to the right. For example, these three, I need to start from the first two, and then this is going to be a value, and this value I'm going to use it with the other operator. So this is how it works. So this is going to be calculated first, 35, 7 times 5, 5 times 7, and then the second thing is this one, 7 divided by 2. What is 7 divided by 2? Very good. 3, because int by int, not 3.5. And then the other thing is that I need to do this 3 moduli division 5. 3 cards to give to 5 people. How many cards are left with me? 3, so this is going to be 3. And then the second thing is, now I need to go from here. What is the minus 2 plus 35? 33. And then
minus 3.
33 minus 3, 30. And this 30, I'm going to put it in y. And the result of this is going to be in x as well. So y is 30, x is 30. Easy, inshallah? All right. So this moduli division, in this slide we did tell you that if you'd like to get what is lost after you put an int divided by int, you use the moduli division. For example, if you divide 15 by 2, you get 7, right? But 7 multiplied by 2 is not 15, because you need to add this 1 over here. It can be, you can get it from using the moduli division. The moduli division is also very useful when we'd like to know if a number is odd or even. If the number is odd or even, then it is going to be, I can know by using this moduli division. Hashim? That's you, right? And the phone is not in your pocket. Next time I will collect your phones. If I'm reminding you that to put your phones in the pockets, I'm going to just to collect them, and then give them to you later on. So this moduli division can be used to detect if a number is odd or even. For example, if you have a number, any number, you give me any number, and then you give me the result of that number with the remainder of 2. If the number result is 0, that means it is even. If it's not 0, it should be 1, then it is odd. Let's take an example. 10, what is the result of 10 moduli division 2?
5.
No, that's 10 divided by 2.
0, 0.
The remainder of 10 cards, if I give 10 cards to 2 people, I give 5, 5, and then what is left? 0. So this is going to give 0, and 10 is even. That's why if it's 0, it's even. What about 15? 15 moduli division 2.
15. 15.
No.
1.
You have 15 cards to give to 2 people. You give 7, 7. What is left? 1. So if the remainder of the division by 2 is 1 of any number, that number means it's odd. If the remainder of the division is 0, that number is 0. Another example, 4 moduli division 2. This is equal to what? 0. And this is even. 3 moduli division 2.
1.
You can see 1. 2 moduli division 2.
0.
That's 0. 1 moduli division 2. 1 card to give to 2 people. You give 0, 0 to each one of them, and then you keep 1. 0 divided by moduli division by 2. Okay, so this is just to explain what the moduli division can be used for. Alaikum salam. There's one interesting thing that, another shortcut that we use is this increment and decrement operators. However, they come in 2 flavors, and these flavors might be a bit confusing sometimes. So the increment and decrement operators, I just would like to show you an example first before, but let me just explain this first. This increment operator, actually, this is how it works. Imagine I declare int, this seems to be t, int x, wow, I don't know what's happening, x is equal to 5, alright? I don't know, by the way, every time I'm giving examples, this 5 keeps coming up. I don't know why. So let's say if I would like to do something like this, x plus plus. This is a valid Java instruction. What this instruction is saying, it means exactly the same thing as writing x equal x plus 1. Only 1. 1. So if I do x plus plus, inside of x it should be 6. The same thing with minus minus. X minus minus means x equal x minus 1. 5 minus 1, that means 4. Okay. Always 1. And there's no multiplication, multiplication, division, division. It works only with plus plus and minus minus. Okay. However, this is easy. This is the easiest part. The other part, which might be tricky a bit, you have to pay attention to it, and then inshallah we're going to let you go. Okay. But I need you to focus now for this, and if you don't focus, you're going to get lost. There are 2 ways to use this plus plus. It can be after the variable, like I said, n plus plus, or plus plus n. And now it has a meaning. It doesn't have a meaning if it's alone. It has a meaning when it is used in somewhere like this, for example. In this operation, I'm using a lot of different things. So let's have a look at this. Imagine we have n, okay? N I put inside of n2, okay? And let's call it m. Inside of m, I have 2 multiplied by plus plus n. And I have, let's say this is the first scenario. The second scenario, I'm going to be using m is equal to 2 multiplied by n plus plus. Actually, it looks the same, but it's not the same. Let's understand. Okay, this means there are 2 instructions. Add 1 to n and multiply whatever is n by 2 and put it in m. The same thing here. There are 2 instructions. However, the order is different. When I'm putting plus plus n, this is what it means. This means this. It means that first thing I do, n equal n plus 1. The second thing I do, m is equal 2 multiplied by n. While in this scenario, the plus plus is after. That means the first thing I do, m is equal to 2 multiplied by n. and n is equal to n plus 1. Do you think that the result is going to be the same? For n is the same, but for m is different. Let's focus on seeing what would be the result of each one. Let's say this is n, and this is m in this case, and this is n, and this is m. Both cases n is 2. So in this, if I'm executing this thing with plus plus before, the first thing I do is add 1 to n. So n becomes 3. Why? Because n equal n plus 1, this is what it happens. 2 plus 1, that's 3. I'm putting 3 inside of n. Now I'm just focusing on this, how this is going to be represented, okay? So if I put the plus plus before, I'm adding the first. I'm adding before. And then now if I'm using this, 2 multiplied by n, what's inside of n? 3. So this is going to be 6, and I'm putting 6 in m. So in this case, plus plus before, I started with the incrementation, n will end up being 3, m 6. Now if I'm doing the opposite, if n plus plus is before, 2 multiplied by n, what's inside of n? 2. So this is going to be 4. And then n plus 1, 2 plus 1, 3. So this is going to become 3. So you see, for n it doesn't change. It doesn't change because it's the same thing. But for m, it is different based on the order of the plus plus. You're not going to be using this every day. Just know that if, in case you see it, you understand it. Okay? For you, how to remember it, if the plus plus is before the variable, we start with the incrementation. If the plus plus is after, we end with the incrementation. Okay?
What is the incrementation?
This is the incrementation. When you add 1 to
To the value itself?
yeah, to the value itself, this is called incrementation. You increment, you add 1, you decrement, you decrease by 1. Alright? Is this clear, inshallah? The rest is going to be very easy. So that's it. Very important to get the textbook. You have it, right? Some of you don't have the textbook. I mean, we're basing everything from it, so you have to get back to it. Okay?
That is written for 1.3, yeah?